All right, today we're going to do our review. We did our celebration of circles review yesterday. Today we're doing chapter 10 review for our test that's on Monday, or well, next time I see you. This was matching, guys. So what was F? It's a point of tangency. Okay, that's a point of tangency. It's the point where the tangent line hits the circle. It's the only thing you could have figured out. FE, that is a tangent line, and it's in between the circles, so it's an internal tangent. That would be H. HG is a radius. Sure you got that. Segment DB is a chord. It's a segment. Chords are segments with endpoints on the circle. Point C, of course, is the center. Choice D. Segment B to E is all the way across the circle through the center, so it's a diameter. That would have been C. And line DB, now you may not have known what that was, but I only mentioned it like once. We didn't do section 10.6, which was about secants. Line BD passes through the circle, and that would be a secant. And last, AG is a tangent on the outside of both circles, so that's a common external tangent, F. Okay, find the value. I'm sure you knew these were equal because they come from the same point on the exterior of the circle. Two tangents would be congruent. So 2x plus 3 equals 10. I hope that you subtracted 3 and got 7 and divided by 2 and got 3.5. How many of you are just working on this right now? I think most of you probably gotten done through those. I know you were trying to work. All right, when I do these problems, if I see I have to do a whole bunch of measures of arcs, I like to look at the picture and say, well, what could I figure out right now? Just by looking at the angle measures that are given. So can somebody tell me how to find angle MTR right here? What would I do? It says MQ and NR are diameters. So what are you going to do? Yeah, 180 minus 64, which would be 116. Okay, and then I would probably say, well, 64 is vertical with this angle over here because these diagonals intersect one another. So this would be 64 degrees. And then we could find this angle by doing the diameter. Did anybody figure out this angle? Take 180 minus 64 minus 39 maybe. It's 77. Yep. Okay, now I'm going to go find these answers. NQ. Arc N to Q. So now I'm just going to do 77 plus 39. Now it's 116 degrees. N through Q to R is half of a circle. So that's just 180 degrees. Semicircle. Arc QR would be 64. MR, we already figured out, 116. PQ, 39. Already labeled. Remember the arc measure is equal to the measure of the central angle. P, let's see, I better color that one. P through R to N. I can't go that way, I gotta go this way. So that's everything but the 77. So I'm gonna do 360 minus 77 and get 283. And then finally, M, Q, N. M through Q to N is everything but the 64. M through Q to N. All of it but 64. So I do 360 minus 64 and I get 296. Good? All right, next. This I stressed yesterday. about remembering the relationship. If you have a quadrilateral inscribed into a circle, then opposite angles are supplementary. They add up to 180. So x plus 73 equals 180. I go ahead and subtract 73 from 180 and I get 107 degrees. Going the other direction, the same is true. Y plus 144 is 180. I subtract 144, and what's that? 36. Any questions about 17? All right, 18 then. I drew this picture for you quite a few times. Make sure you're reading what we want to find. We want angle BAC. The central angle BRC is 104, which means the arc's 104. How does the angle BAC relate to the arc it intercepts? It's half, okay? This angle would be half of 104, so it's 52 degrees. 19, that's not your 19 because I eliminated some questions that we used to section 10.6 on secants and some other things about arcs. Anyway, this is your 19, correct? All right. This I would pay very close attention to because there would definitely be something like this on the test. I want to find d to y. So I'm going to put an x there. It says c to y is 12, but you can't assume it's cut in half. Can't do that. But this radius does cut in half the chord. So but then it says AD is 8. Okay, so I'm putting 8 there. 8 would be here too, though. Find dy. Well, I want to find this segment right there. What can I do to find it? I don't have any more stuff except I know y to c is a radius and it's 12. I've got a right angle there, right angle here, etc. There's 4 right angles. Okay, that's it. And don't we have an example like this in our ISN, I believe, something similar? You'd connect A and Y to make a radius. That's what Nathan said, and yes, that was the correct way to explain it. He said, draw a radius from A to Y, which would be 12. Now I can do Pythagorean theorem to find dy. So x squared plus, good luck, you're welcome, x squared plus y squared, 8 squared, excuse me, equals 12 squared is your equation set up. So you go ahead and evaluate your squared terms, and then you subtract 64 from both sides. We get x squared equals 80, and then we take the square root of 80. On your calculator, type square root of 80, please. Everybody should have a calculator open and using it. Come on. The 8.9. I didn't have any unit. Oh, it's in centimeters. Yep. So I had units. Now to find DC, this is clearly not to scale, but y to c is 12. So if this is 8.9, I'm going to do 12 minus 8.9, and that's 3.1 centimeters. Okay, everybody understand? I wanted D to C. I subtracted, this was 8.9. I had to subtract it from 12. That's radius. All right, 24. We are given that N to E is 15. That is the radius. R is 15. Any radius in the picture. NK equals NH. Okay, so these little segments are equal. KX is 10. All right, here's what these little things mean. NK being congruent to NH means that these chords are congruent. And the chords are bisected by the radii. So all of these segments are congruent. Which means since one of them's 10, they're all 10. All right, that's the information I've been given. Now I'm asked to find NG. NG is a radius. How big's the radius? 15. So it's 15 millimeters. Now it says to find D to E. Well, we already got it labeled. It's 10 and 10, total of 20 millimeters. And now it wants to find N to H, so I'm going to put an X there. And I'm going to do the Pythagorean theorem on that little triangle. X squared, goes to leg plus leg squared plus leg squared, x squared plus 10 squared equals hypotenuse squared. So I work this out. I subtract 100 from both sides. I have x squared is 125, so I take the square root of 125. And let's see. Square root of 125 is like 11 point something, 11.2 millimeters. Any questions about that problem? Okay, moving on. Oh, by the way, I know these are numbered wrong. Could you tell me what your number is on for this next one? The diameter of a circle is 7? 21? Okay, so I'm behind. Okay, that's better. If the diameter of a circle is 7, find the circumference of the circle to the nearest hundredth. Circumference is pi times the diameter. You've been given the diameter is 7, so the circumference is pi times 7. Couldn't be easier than that when you're given the formula. So we hit pi times 7. We got 21.99 to the nearest hundredth. And that would be in feet. If the circumference is 49.3 inches, find the diameter in radius. Now it's telling me the C value. Since circumference is pi times the diameter, I'm going to put in 49.3 for the C. We have an example of this also in our ISN. We divide both sides by pi to get the diameter. So grab our calculator, we type 49.3 divided by pi. And that's our diameter, 15.69. And it would be in inches. Now, to get the radius, we will divide that diameter by 2. So I'm just going to hit divided by 2 and round to the nearest hundredth, 7.85 inches for the radius. 23. All right, I want to find this little piece right here, but I can't really find it directly. I should know that if I have a tangent and I have a radius drawn to the point of tangency, what's right here in this corner? What's this? It's a right angle. It has to be a right angle. Okay, over here, there's a right angle right there as well, because again, tangent and a radius are perpendicular. All right. I can find this entire hypotenuse using the Pythagorean theorem. So I'm just going to call this y. So y squared would equal 10.5 squared plus 10 squared. So grab your calculator and get those numbers squared and added. Okay, I'm going to write the whole thing down to 10.25. Take the square root of it. What am I going to do after I find this answer, though, to get the piece I really want? I got 14.5. That's the whole hypotenuse here. what is this piece that I don't need? Oh, that's the radius, that's the radius. This would be 10. So how big is it from here to here? 14.5 minus 10. So the question mark part is equal to 4.5. So something similar for this one. All you want is the radius, but you're going to be able to find the diameter. So if I call that y and this x, I don't really care what you name them. We got to do Pythagorean theorem. This would be a leg, this would be a leg, this would be the hypotenuse where the 15 is. Okay, so leg squared plus leg squared, y squared plus 9 squared equals 15 squared. If you evaluate those, y squared plus 81 equals 225, and then subtract 225. I'm not subtract 225, subtract 81 from both sides. Is that 144? And then take the square root, so y is going to be 12. All right, so if that's 12, then how big is the radius? The diameter is 12. The radius would be half of that, so it'd be 6. So the answer is the question mark equals 6, or whatever. All right, the next one. Oh, I forgot what numbers these are on your paper because we changed them. 25. Oh, so it's just 4 back. All right, and this is 26. We're pretty successful with these. What you need to remember is if you're coming from the same point outside the circle, two tangents are congruent. So if that's 10.2, this is 10.2. Okay, these two would be equal. How am I going to figure out what they are? I got 10.2 here. The whole thing here is 21.2. Yeah, subtract. What's 21.2 minus 10.2? 11. So 11 here and 11 there. And then I got to figure out these two, which will be equal. So I got to take away 11 from 17.2. And they're, yep, 6.2 apiece right there. So now it says to find the perimeter. The perimeter is when you add up all these numbers. Add them up, please. I just added them up. Is it 54.8? Okay. Let's go for the next one. If you got a 5.9 there, you got one up here. 9.3, another 9.3. I think I just like to color these. 12 and 12. Put them all together. $24, $34, $31. What is it? 54.4. Would that be agreeable? Are you guys agreeing with that? Okay. All right, let's move on to one more. You guys find the perimeter, please. There was a question very similar to this on the last quiz, and it would have said, it gave a bunch of all the stuff, and then people wrote down, what if they asked you what this is, the length of this side? What would you do? You'd add those two numbers. I had people write they couldn't tell how to get it. I don't know why they didn't just add the numbers. I don't get that, but you would just add the side. You couldn't get the length of these sides. This is 5.5, so this is 5.5. I subtract 5.5 to figure out that this is 10. And this is 10. The ones you want to add are The ones you figured out. All those pairs. What we get here? Is it 44.8? Thank you. I don't know why we didn't get any units, but we didn't. And again, I forgot to write down what number this is. I believe it's 28. Find the exact circumference. What does that mean? Leave what? Leave a radical or pi in the answer. All right, exact. So circumference is pi times the diameter. It means you don't want to type pi in your calculator because it's going to become a decimal then. So we need to just find out the diameter, and that would be 32. So it's just 32 pi, and then you put centimeters on it. And you put the pi after the 32. I mean, it's not really wrong to have pi times 32, but that's what it's going to look like, if, in particular, if it's multiple choice. 29, Pythagorean theorem, and then find the exact circumference. Circumference is pi times the diameter, so we're going to figure out the diameter by Pythagorean theorem. D squared equals 5 squared plus 12 squared. Yep, that's 169, and then you take the square root, and you get 13, right? And then you say, okay, circumference is 13 pi, and it'd be in feet. Yep. I went kind of fast. I think you got it. 30. We did real well with this on the last quiz. I need to know this arc right here because the angle is half of the arc. First, let's figure out, hey, that's the diameter, so that's half a circle. So what is the blue part? And what's the measure of it? You have 180 minus 105. So this is 75. And then what do you do to get x? Divide by 2. All right, so it should be 37.5 degrees. I wrote 20. Oops. 37.5 degrees. Find the segment length indicated. Assume the lines that appear to be tangent are tangent. This is 31. What are we going to do? There's 2 ways I've taught you to get this answer. One of them uses Oscar and his apples, or SOHCAHTOA. The other way is by special right triangles. If you do special right triangles, yep, that's 30, 60, 90. I'll show you. Again, I'll remind you of that pattern. It was a right triangle where you had a 30, 60, 90, and the side opposite the short was a short leg. The long leg was n times the square root of 3, and the hypotenuse was 2n. What do you got? Short leg. You want hypotenuse. So it would be 2 times 8, which is 16. Now, some of you do not get that pattern. What is the other way you could do it then? From 30, where is this? Think opposite, hypotenuse, adjacent. This would be, bless you, opposite the 30, and this would be the hypotenuse. Remember, Oscar has a heap of apples, or SOHCAHTOA. This is the sine, cosine, tangent. We would be using the sine. So it'd be the sine of 30 equals 8 over x. And then you would have to remember that when you have x in the bottom, you have to do cross products. X times the sine of 30 equals 1 times 8. Well, you always do cross products in a proportion. However, you're going to need to divide. So 8 divided by sine 30 is the other way to get it. If you type 8 divided by sine 30 on your calculator, it will give you the correct answer of 16. Doesn't matter to me which way. All right, 32. Oh, how do I do this? Somebody want to make a suggestion? What? 360, then do what? All right, subtract both those to get what's left here. All right, that is the first step. Find that. 100 and something. Come on. The 155. All right, that's not the answer. It's once the measure of angle A, B, C. And that's not 155, it's half of that. Okay. 77.5 degrees. Great. 33. Okay, trickiest one. Wait, no, this isn't the trickiest one yet. I got one harder, I think. I want to find BD. I have CE is 13.5. Let's divide that by 2 because this radius bisects that chord. 6.75, right? This is a right angle here. Radius is perpendicular to that chord. Now, round to the nearest hundredth. C to E, okay, 13. Is this all I have? Now I got a right angle. I got to find that. So I better put in a radius from C to B. How big is that? Same as this, 8. So now I can find B to D by Pythagorean theorem. X squared plus 6.75 squared equals 8 squared. We will need to subtract. So why don't you just type 8 squared minus 6.75 squared. Okay, and then that's 18.4375. And then take the square root. I just like to pop that answer back in there. And you should be getting 4.29. All right, so BD is 4.29. Next, 34. Well, I'm going to write down part B right now as I go through this question. How am I going to solve for X and find the measure of angle T? I'm going to use proper vocabulary to explain how I'm going to create my equation. First thing you need to know is that angle S is what? Okay, angle S is an inscribed angle. Inscribed angle that intercepts a semicircle. It intercepts a diameter, which means it's going to be how big? You can say it intercepts a diameter or a semicircle. So how big is that angle? Guys, this is how much? That's a semicircle. That's 180. So how big is this? 90. Okay. So it is 90 degrees. All right, you've got a triangle there. The angles of a triangle add up to how much? Add to 180. So that's where I got my equation. That's just in your own words, sort of. I wrote it similarly in the key. So let's do it now. The angles add up to 180. So we've got 4x plus 6x minus 8 plus 90 equals 180. 4x plus 6x is 10x. 90 minus 8 would be plus 81. Nope, 82 equals 180. Subtract 82. Get 10 times x is equal to 98, and then divide by 10. So x is 9.8. It also said to find the measure of angle T. So we go 6 times 9.8 minus 8. Would somebody please calculate that? Or everybody should be. Was it 6 times 9.8, and then what do I have to do? Subtract 8, thank you. All right, so we should have 50.8. Is that what you guys got? I think I typed it right. All right, so why did we have that equation? It was because angle S was an inscribed angle that intersected a diameter or semicircle, so it's 90 degrees, and the angles of a triangle add to 180. That's where we got our equation. That 35 and 36. Find each measure. This is the trickiest one. There's actually two ways to do this problem. As MN is 16, this radius bisects that chord, so both of these would be 8. Arc MLN is 98. MLN down here is 98, and that chord cuts the arcs in half, so they'd be 49 each. 98 divided by 2 is 49. So arc NJ right here would be 180 minus 49. Is that 131? Okay. Now, they're asking me to find LN, which is here. I got a right triangle there, and I got a right triangle here. I also know the radius is 10. So I better draw in another radius right here from K to N, which would be 10. I got a leg that's 8. I'm going to have to find KP. So I'm going to call that whatever, X. Leg squared plus leg squared equals hypotenuse squared. X squared plus 8 squared equals 10 squared. I'm going to subtract 64 from 100. And I take the square root of 36 and get 6. Well, if that's 6, then how far is it from here to here, from P to L? This is a radius, which is 10. So if I do 10 minus 6, I get 4. And guess what I'd have to do to get LN now? You got a right triangle again right here. The LN would be its hypotenuse. So you can do 4 squared plus 8 squared. Okay, so 4 squared plus 8 squared equals LN squared. I don't know, 16 plus 64 is 80. And then we would take the square root of 80. That's about 8 point, what's that to the 100th? It's 8.94. Now, I went a little quick through that, as complicated as it was. I don't think I'd put one quite that complicated on your test. There's one other way we could have found it. We could have figured out this angle is half of 49, and we could have done trig, opposite over adjacent. Let me show you what I mean, because this is actually faster. And check if I get the same answer. See how this is an inscribed angle right here? That angle right there, where the N is, would be half of 49. That's 24.5, right? And then this is 8, T to N, and P to L is 4. I guess I could. Then I could do opposite over adjacent, so it would have been in a tangent, a 24.5 equals 4 over 8. Oh, wait, that doesn't make any sense. Why did I do all that? Guess I could have, I wouldn't have had the 4 there. That's the point. So then I could have done adjacent over hypotenuse, and I would have done cosine. Anyway, we don't need to do that. But just hold off a second. It's not quite time to go. I'm going to help you with this so you will have the proper equations. You're doing x degrees out of 360 times pi times the diameter for these. Guys, you're not lining up. This is 100. What would this angle be if that's the diameter? 80. Okay, so then if you wanted to do RT, but that would be 50 out of 360 times pi. And MT is a diameter, so times 7. This one, if you're doing NR, it's going to be 80 out of 360 times pi. And then you got to check if PR is a diameter. It's not. Since PR is a radius, you would need to plug in 26 for the diameter. Okay. And let me show you the last two setups. And I know you guys know how to type this on the calculator. So 43, you got the same picture. This was 80. This would be 50. Okay, this would be 130. And it's saying MST. Oh, that's half a circle. 180 out of 360 times pi. MP is only a radius, so you'd need to put in 4 for diameter. And the last one, MRS. M to R to S would be 180 plus 50, 230 degrees out of 360 times pi. And NS is a diameter, so you'd put in 10. Bless you. All right, those are the last problems. Be ready for your quiz. You can check those last answers at the bottom. Have a nice weekend.